All right, next up, guys, this lesson's on similar solids. So, real quick, in order to do this lesson, you either got to have a graphing calculator or you can have just like one of these little guys too. So, you need to figure out where the cube root function is. So, cube root is like that's a square root. This is a cube root, okay? Square root of something or cube root of something. So, where that button's at in the calculator, if you go to math, it's this button right here. My finger's at. If you hit math, it's the fourth option down. Number 4 right there. That's your cube root. So if you're cube rooting something, you type that, and then it'll give you the answer. So if I click on that and I want the cube root of, say, 9. Let's go an easier one. How about let's go 8. It comes out to 2. Okay. If you have a little guy like this, we do the same thing. You just gotta type the 3 first for the cube. So type 3, and then you gotta hit second this button right here. So second, the up caret, that's your cube root. Then cube root of 8, once again, it comes out to be 2. Okay, so both calculators do it. You just gotta know where the buttons are at. So when I reference the word cube root, this is what I'm doing, okay? All right. Similar solids. First bullet, similar solids have exactly the same shape, but not necessarily the same size. Two solids are similar if the ratio of their corresponding linear, and I'll talk about examples of this in a second, linear measurements are equal. Okay, so what are linear measurements, right? What are you talking about, Foss? So types of linear measurements could be length of something, could be the width, could be the height, and we're going to use every single one of these today. Slant heights, perimeter, so that also works. Radius will work. Diameter will work. And last one, circumference. So those are all types of linear measurements: length, width, height, slant height, perimeter, radius, diameter, circumference. We can use all of these to figure out if something is equal according to the ratio of the two things. So here's some examples. These will definitely be on the quiz. Determine whether the solids below are similar. If yes, give the scale factor in simplest form. So just remember, guys, reduce. Always reduce your fractions. Reduce, 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 reduce. All right, so they have 3 measurements. We got to line all 3 up and see if they're reduced to the same thing. So we can use height. Let's go big to small. We'll go 12 over 3. And that reduces to 4 over 1. Always reduce. The lengths, let's go 8 over 2. That reduces to 4 over 1. And the widths, 20 over the 5. That also reduces to 4 over 1. So since they all reduce the same thing, yes, these are similar. So yes, they're similar. All 3 measurements reduce to the same exact thing. Number 2, you got a square pyramid here. All right, so once again, match up all the sides. So let's go the length in the bottom. We'll go 6 over the 10. We'll go small to big, 6 over 10. That reduces to 3 over 5. The widths, 6 over 10. That reduces to 3 over 5. And then the heights, 8 over 12. That also reduces to, oh, no, that doesn't. That reduces to, divide top and bottom by 4. That reduces to 2 over 3. So no, this guy was not the same as those two. Number 3, we have a diameter, and then we have a height. So now check us out. This is a diameter. That's a radius. So either I got to cut that in half or I got to double that to do the same thing. So I'll just double this. And then the diameter now is 20 inches. So now I can go diameter, diameter, height to height. So diameter to diameter, 24 to 20. That reduces to 6/5. And then the heights, 30 over 25. That also reduces to 6 over 5. So yes, they match up. They are similar. And the scale factor is 6 to 5 if you're going that to that. All right. Next section, comparing volume and surface area. If two solids are similar with a scale factor of, let's just use A to B, then their volume and surface area ratios are as follows. So surface area, we square the ratio or square the scale factor. For volume, we cube the ratio or cube what you can call it scale factor, either way. But if you want to find the ratio of their areas, you have to square the scale factor. If you want to find the ratio of the volumes, you have to cube the scale factor. All right, so here's how this works. So identify the scale factor first, and then find basically surface area, and then find the volume. Okay, so I can use any one. I can use the length, I can use the width, or I can use the height. Just pick one of them and reduce it. I'm going to use height 6 over 3. That reduces to 2 over 1. That is the scale factor, 2 to 1. Now, to get surface area, I have to square. I square this and I square that. So this would be 2 squared to 1 squared, which equals 2 squared is 4, 1 squared is just 1. Okay? To get volume, you have to cube the scale factor. So 2 cubed to 1 cubed. 2 cubed is 8. 1 cubed is 1. Scale factor, to get to the area, square it. To get to the volume, you have to cube. More work, same stuff. Let's use the radius instead of slant height to reduce. The number looks kind of gross to reduce. So radius 4 to 6. That reduces to 2 to 3. Scale factor then is 2 to 3. To get to the scale factor, from scale factor to surface area, we have to square, remember? 2 squared is 4. 3 squared is 9. To get volume ratio, we have to cube. 2 cubed is 8. 3 cubed is 3 times 3 times 3, 27. Number 6. All right, when given a surface or volume, always find the scale factor first. Always, always, always. This is going to come in handy a little bit here, so let's highlight that. All right, so we're given surface area. Find scale factor first. So, okay, well, how do I do that? What did you give me here? All right, so surface area was 25. The left guy's surface area on the right was a 4. All right, this is your a squared, b squared, right? So to go backwards, I had to square to get here. I have to square root to get back. So to go backwards, you have to square root. Okay? To get there, I squared. To go back, I square root. So if I square 25 squared over 4 squared, that comes out to be 5 over 2. That is your scale factor. 5 to 2. We were given this, and I have to square root to go back. Square root to go back. Now, to go from here to here, I just have to cube. 5 cubed is 125. 2 cubed is 8. 2 more. This time they give us volumes. They give us the volume ratio, right? Volume is 162 to 384. Always finds scale factor first. So to go from here to here, I have to do what's called a cube root. And that's what I showed you guys on the calculator when the lesson first started. So refer to that to figure out how to type it in. Oops, went the wrong way, this guy. But it would work for the bottom one too, right? All right, so when you type in the cube root of 162 to save some time, numbers. I forgot one thing. Backwards, back up, back up, back up, back up, back up, back up. The rule is we always have to reduce a fraction when given, okay? Always, always, always reduce first. So before I can do this, we got to reduce this fraction. To save you some time, if you type this in your calculator, it reduces to 27 over 64, okay? If I had to reduce up here, if I just reduce, I would have had to done that first. But since this did not reduce, I just had to do it right here, okay? Because it could reduce. So this real number is 27 to 64, okay? Always reduce first, then find your scale factor. All right, so cube root of 27, that comes out to be 3. Cube root of 64, that comes out to be 4. Now, to go from scale factor to surface area, we just have to square. 3 squared is 9. 4 squared is 16. Done. All right, we can kind of get rid of this one, right? We didn't have to use that one. All right, this time it's giving us surface area, right? All right, so it's 960 over 375. I can reduce that. That reduces to 64 over 25. All right, so surface area, give us a surface area, 64 to 25. Okay, find scale factor first. To go back, we have to square root, just like we did on number 6. To go back, we had to square root. So I had to square root these numbers to go back. So square root of 64 is 8. Square root of 25 is 5. Okay. Scale factor to volume. This way, I just have to cube. 8 cubed is 512. 5 cubed is 125. All right, so just a quick review of that same page. If I'm going from scale factor to surface area, I square. If I'm going from scale factor to volume, I cube. To go backwards, if I'm going surface area to scale factor, square root. If I'm going from volume ratio to scale factor, I have to cube root, okay? Squaring, square root right here. Cubing, cube rooting from scale factor to volume. All right, moving on. All right, so quiz questions continued. It says, recall the ratios for similar solids or scale factor. These are your linear measures. I would write this down. That's what we just called it A to be. That's like height, width, slant height, perimeter, radius, circumference, diameter, yada, yada. Surface area, we square the ratio. Volume, we cube the ratio. All right, important. This is why I had to go back on the one on the previous page. I didn't reduce first. Always reduce the ratio of given measurement. I forgot to do that. Then find scale factor first. Okay. Reduce, find scale factor first. All right. If the cones below are similar, what is the ratio of surface area? So here's what I'm looking for. I want surface area of the larger cone to the smaller cone. Okay. Well, they're giving us a linear measure, right? So they're giving us A over B, right? Which is 28 over 8. But first, I should reduce 28 over 8. 28 over 8 reduces to 7 over 2. Reduce first. So A to B is 7 over 2. I'm looking for A squared over B squared, right? I want surface area. Okay, 7 squared is 49. 2 squared is 4. Boom. There you go. There's your answer. 49 to 4. You can also write it 49 to 4. Both work. Doesn't matter. It means the same exact thing. Okay, number 2. If the pyramids are below or similar, what is the ratio of the volume of small pyramid to big pyramid? Okay, it gives us a linear measure, right? First thing I have to do is reduce. 16.5 over 22. If you type that into your calculator and get the fraction, it comes out to be 3 over 4. That is my A to B. That is my scale factor. I want volume. I want A cubed to B cubed. Okay, 3 cubed, 3 times 3 times 3, 27. 4 times 4 times 4, or 4 cubed is 64. That is your answer. You can also write it 27 to 64. They both work. Number 3. If the cylinder is below a cylinder, what is the ratio of the radius? That's what I'm looking for. Basically, remember, I'm just looking for a scale factor, right? It's a linear measure. The larger cylinder to the radius of the smaller cylinder. Okay, what are they giving us? They're giving us the surface area, right? So first thing, reduce the fraction. 116 over 29. That reduces to 4 over 1. Okay, that is my A squared to B squared, right? 4 to 1. I am looking for radius. I want just A to B. Okay, going backwards, right? Scale factor to surface area squared to go back. To undo a square, I have to square root. I have to square root to go back. 4 squared over 2 squared. Square root 4 is 2. Square root, which I should be the 1. Square root 1 is just 1. Square root 4, square root 1. That's your answer. 2 to 1. Number 4. If the prisms below are similar, what is the ratio of the height? So I'm looking for a scale factor. Small prism to big prism. All right, you're given volume. First reduce. 15 over 405 reduces to 1 over 27. Okay, what is this? This is the volume, right? This is A cubed to B cubed, which is 1 to 27. I want the height. I just want A to B. To go back, you have to cube root. Cube root of 1 is 1. Cube root of 27 is 3. That is your answer, 1 to 3. Number 5. The pyramids below are similar. What is the ratio of the volume of small pyramid to big pyramid? All right. Gives us surface area. First, we got to reduce. 52 over 325. That reduces to 4 over 25. Okay, let's see here. What is that piece you just gave me? That is the area. That is my A squared to B squared, 4 to 25. I need volume. I need A cubed to B cubed, right? But first, I got to find scale factor first before I can find the volume or the area, right? We were given surface area. To get here, I got to find this first. So, given the square, I have to square root to go back. So, to get just A to B square root of 4 is 2. Square root of 25 is 5. Now, I can go to here. Since I have the scale factor, now I just got a cube, right? Take your A and cube it. 2 cubed is 8. 5 cubed is 125. There's your answer. Find scale factor first. Then you can find surface area or volume. Number 6. The prisms below are similar. What is the ratio of surface area of larger prism to surface area of smaller prism? Okay, what are we given? We're given volume. First reduce. Over 128. That reduces to 729 over 64. Okay, what is this? This is A cubed to B cubed. What do I want? I want surface area. Okay, but first I have to find scale factor. Remember, you gotta find scale factor first. I need A over B. So we're given the cube. To go back, I have to cube root. Cube root of 729 is 9. Cube root of 64 is 4. Now I can go here. To get the surface area, just square the number. 9 squared is 81. 4 squared is 16. That's your answer. 81 to 16. All right, let's see here. Last section. Find a linear measure, surface area, or volume. Use proportions. All right. So what are we going to set to solve this thing? The ratio of the diameters of two similar the ratio of the diameters of two similar cylinders is 3 to 5. If the surface area of the smaller cylinder is this, find the surface area of the larger cylinder. Okay, we're trying to find surface area. What are we going to use? A squared to B squared, right? That's what we're going to use there. What are we given? We're given the ratio, right? So the ratio, A to B, was 3 to 5. All right. Ratio of areas, if I square them, 3 squared is 9. 5 squared is 25. Okay. Now we set up using proportion. Okay. Remember, proportion was this, right? Set up the proportion. Ratio of areas 9 to 25 equals surface area of smaller cylinder is 378 over the unknown of the larger, right? Cross multiply this times this. 9 times x, 9x. 25 times that is 9,450. Divide both sides by 9, and x comes out to be 1,050 square inches. Talking about square inches. Use our ratio to find a missing linear measure, surface area, or volume. Number 8. The ratio of the surface area of the two similar solids is 16 to 9. If the volume of the larger is that, find the volume. Okay, find the volume. I know what I'm using. A cubed to B cubed to find the missing volume, right? What are we given? We are given the surface area. I'm given the A squared to B squared, which is 16 to 9. Okay? A to B. Remember, I square root to go back. Square root 16 is 4. Square root 9 is 3. I'm going to use A cubed, B cubed. Square the ratio. Cube the ratio. 4 cubed is 64. 3 cubed is 27. All right, proportion. 64 to 27. 290, let's see. And we're going to find the volume of the, okay, this is large pipe. This is small pipe. Oh, for large, small pipe. We got to find the volume of larger, right? So this is large to small. This has to be large to small, okay? So the large pipe, we don't know, call it X, but the smaller one is 297. Make sure your proportion, right? Large to small, large to small. Cross multiply. 27 times X is 27X. 64 times that is 19,008. Divide both sides by 27. 704 cubic centimeters. Number 9. If the prisms below are similar, find the value of X. Okay, so find the value of X. That means they just want a ratio, A to B. What are we given? We are given the volume, right? All right. So first set them up, then we got to reduce. Always reduce, 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 reduce. 840 over 105. That reduces to 8 to 1. Kind of nice. Okay, so what is that? That's the volume, right? That's A cubed to B cubed, 8 to 1. All right. Ratio, we need A to B because that's what we're using, right? So how do we go that? How do you go back from a cube? Cube root. Cube root of 8 is 2. Cube root of 1 is 1. All right. Portion time. All right. So if I go large to small, 2 to 1, I can go large side to small side, 20 to X. Cross multiply. 2 times X is 2X. 20 times 1 is 20. Divide by 2. X is 10 centimeters. Last one. Cone A and cone B are similar. If the surface area, so we're given a surface area of cone A is 108. The surface area of cone B is 147. If the volume, they're giving us volume, we need to find some volume. If the volume of cone B is this, find the volume of cone A. So I'm going to use A cubed to B cubed. All right, so first reduce 108 over 147. That reduces to 36 over 49. Okay, what is this? This is the surface area, right? This is the surface area. This is A squared to B squared, 36 to 49. But first, we got to go there, right? Remember, always find scale factor first. Square root to go back. Square root 36 is 6. Square root 49 is 7. I need the volume. Cubed to go here. 6 cubed is 216. 7 cubed is 343. All right, now I can set up my proportion since I have the ratio of the volumes. Proportion 216 over 343. So I am going from small to big. They're saying the volume of cone B is this right here. All right. So cone A to cone B, cone A to cone B. Make them sure they match up. Cone A to B, cone A to B. X over 857.5 cross multiply. 343x equals, oh boy, 185,220. Divide both sides by 343. Answer is 540 cubic millimeters. That is it for your lesson on ratio, aka scale factors, similar surface area, and volume.